In this video, we'll take a look at linear inequalities in two variables. So it brings back a little review of graphing also. So that's not a bad idea. Um, all right, so this right there you see a line, and this line has an equation y equals 1/3 x plus 3. That's the line. And notice the equation. It's y equals 1/3 x plus 3. What that means is that the y value is exactly equal to that. And we know this. Every dot along this line, the y value will work out to be 1/3 the x value plus 3, right? So for instance, if you take 6 as the x value, you put in 6 there when x is 6. Let's see, when x is 6, we have y equals to 1/3 times 6 over 1 plus 3. This is 6 over 3 plus 3, that's 2, that's 5, right? So in other words, 6, 5, and you can see that 6, 5 right there. So along this line, y is exactly equal to that line, that value, that right side expression. But what if you get off the line, right? What if we are over here? So that point right there is 2 and 5, right? What happens now? So let's see. So y is 5. Y is 5. And what about the right side? Well, we have 1/3 times 2 plus 3. So this is the left side of the equation. This is the right side of the equation. And so this is 2/3 plus 3 over 1. And we can do simple grocery store math. 3 pounds plus another 2/3 of a pound gives me 3 and 2/3 of a pound. And here is 5. Well, clearly 5 is bigger than 3 and 2/3 of a pound. So you can sort of see this area, all these dots over here that I'm just kind of shading in, all those dots will result in y being greater than 1/3 x plus 3, like we just saw with that one test point. What if you picked a point below that line, right? So what if I pick that point? 0, 0, 0, 0 is always very nice and easy to use. So y is 0 on the left, and what about the right? Right, so we have 1/3 times 0 plus 3, so this is 1/3, excuse me, it's 0 plus 3, so that's 3 and 0, and clearly y is less. So in this side, y is less than 1/3 x plus 3. So over here we say y is less than 1/3 x plus 3, and on this one we would say y is greater than 1/3 x plus 3. Now you can't automatically assume everything above the line is greater and everything below the line is less. You actually have to test, like I just did, to see whether which way it works out. And everything of course along the line is equal. Okay, and so that brings me to inequalities of linear inequalities, right? So for example, let's say we wanted to draw y is less than or equal to 2/3 x minus 3. Well, the first step of this process is to graph the line y equals 2/3 x minus 3. Now the thing about the line is the boundary between where it's greater and where it is less. So if I want to know where is it less, then I first have to know the boundary between less and greater. So that's why you draw the line. So we graph the line any way we like. Perhaps the easiest way is to use the point, the intercept and the slope. So the intercept is -3. So the y-intercept is 0, -3, and the slope is 2/3. So from -3, I'm going to go up 2 and go over 3. 1, 2, 3. Go up 2, another 3, and this was, if I remember right, 1, 2, 3. This was like the most challenging thing for me to do, to draw a straight line. So let's go ahead and draw a straight line as best as we can. Oh dear, this is not going to work out nicely. because of my inability to draw. So okay, so there it is. There's my straight line. It's coming. It's terrible, but you get the idea. And that's the boundary between sort of the less and the greater. Now, how do I decide on whether I should shade above or shade below? For that, what you do is use a test point. So you get a test point off the line, right? So let me take a test point off the line. If 0, 0 is an option, then I always take 0, 0 as a test point. So 0, 0 in this case is an option. So I'm going to use 0, 0. So I put 0 for, so y is 0, x is 0. So I put 0 for y, and I put 0 for x, and I check to see what's going on. So on the left, I have 0. On the right, well, that's 0 minus 3. So clearly it's that, which is not what I want, right? So 0, 0 is on the wrong side. So 0, 0 is on the wrong side of the line, because what I want is y to be less than the right side, not greater. So 0, 0 is on the wrong side of the line. So what do I do? So shade the other side, right? So since 0, 0 is on the wrong side of the line, what you're going to say is, well, all of this is the good stuff. So what you need to do is shade in the right area, the correct area, like so. Now, so in this picture, we have where it's equal and where it's less, right? So in both of which are there. Let's do another example of this. So let's say we wanted to graph the inequality. 3x minus 2y less than minus 6. So first of all, you got to decide how you want to do this, but let me do this one with intercepts, just to review graphing by intercepts, right? So I'm going to use a table for this one. So x, if I made x 0, and so y, so x is 0, minus 2y is equal to minus 6. And so minus 2y is equal to minus 6, divide by negative 2, divide by negative 2, and I get y equals to 3. 0, 3. And to graph by intercepts, I need a second point. I need the other intercept. So this time I'm going to get y 0, and so I get 3x minus 2 times 0 equals negative 6. So 3x is equal to negative 6, divide by 3, divide by 3, x is equal to negative 2. So now I have my 2 points. So what I'm finding here again is the boundary between the greater than area and the less than area. Right? Where did my graph go? I was going to copy this grid over. Let's see, copy, and let's see if I can paste it right there. There it is. Okay. All right. So now let's put these two dots down. So we have 1.0, 3 right here. And we have another dot, negative 2. So starting at 0, 0, negative 2, 0 right there. Now, notice the inequality. The difference between this inequality and this one is that equal, we want y to be less or equal. So equal was okay in this one. So equal, okay, right? On this one, on the other hand, equal is not okay. So how do we tell the difference between equal okay versus equal not okay? You use a dashed line. right? So the line is not included. So use a dashed line when the inequality is strictly less than or greater than. Okay, so I'm going to draw my line, but it's going to be a dashed line. So um, let's see if I can draw this halfway decently. All right, so I'm trying to draw this relatively nicely. So there is a dash line. What does it look like? I'm just to draw this, I'm just using the slope, which is 2 and 3. So 2 and 3 would take me there. So that's another dot. 2 and 3 take me here. That's another dot. So it helps me draw a relatively decent picture. All right, so there is the boundary, and we have to decide whether we should shade above or below. So again, if 0, 0 is an option, I'm going to use 0, 0. So 0, 0 clearly is an option. And let's see if it works out. That's my test point. Okay, so use a test point, get a test point. Okay, so I'm going to take my equation, 3x, what is it? 3x minus 2y, 3x minus 2y less than negative 6. Okay, so let's put in 0 for x, 0 for y, and so I have 0 less than negative 6. So that clearly is not true, so false, because negative numbers are less than 0, not greater. So that means 0, 0 on the wrong side. Right? So don't shade the side with the 0, 0. So, and now you have colored in, you've found the graph of that inequality. All right, so the things to remember: dash was a solid line. That tells you whether the line is included or not. Use a test point to decide whether you should shade above the line or below the line. It's not always clear which way you should go, so always use a test point.